Hey, I'd like to talk today about the different ways that a square can be rotated. Um, as I'll show you shortly, there are precisely 8 ways you can rotate a square. Um, and what I mean is that uh, you sort of rotate the square so that it ends up in a position similar to its original position, but not precisely the same. So I'm going to be using this as my square. So for example, that is a rotation, or that is a rotation. Um, Hopefully I'll also make a video about the rotations of the cube at some point. Now, one of the things to notice is that if you rotate a square one way and then you rotate it again a second way, it's equivalent to some third way of rotating, which would have done it directly. It's like if you do this and then that, you could have just rotated it like that in one rotation. And also, every way of rotating the square could be sort of undone by some other rotation. Sometimes it's the rotation itself, such as if you rotate it this way, and you do that again, it gets back to its starting position. And sometimes it's some different rotation. For example, if you rotate it a quarter turn like this, then you undo that by doing that quarter turn, which is a different rotation. So now I'm going to go through the 8 rotations, but the first thing to note is that we count the rotation of doing nothing as a rotation, meaning doing nothing is something that we consider to be a rotation. Because what we want to be able to say is that if you do 2 rotations, you get some other rotation, and there are some rotations that, let's say if you do them twice, it's as if you did nothing, and so we would have to call that a rotation as well. So, but essentially, instead of viewing it as rotations, you could also view it as different positions I can place this not really square in. So here's the first one, and that's doing nothing. As you can see, these words are on the top now. And then there's the second one, the third one, and the fourth one, and then I get back to where I started. Now, you could do the same for when this is upside down. So there's 1, 2, 3, 4, and back where I just was. And so these 2 sets of 4 make 8, and those are the 8 rotations of a square. Now, there's the rotation of doing nothing, of course. And you can get back to it by doing certain rotations you can do twice to get back to doing nothing. And there's 5 of those. One of them is the one that flips it this way. So if you do that twice, you get back to where you started. The other one I showed you before is that one. You could also do a similar thing to that one, but instead of flipping it over this way, you flip it over that way. And you can do that twice, you get back to where you started. And then another rotation is sort of across a diagonal. It's a bit more complicated, but like I put my fingers here and I rotate. And if I do that twice, I get back to where I started. And I could do that for the other diagonal as well. 1, 2. And so those are 5. There's this one, which gets you back to where you started. There's that one, this one, or that one. And those are 5. And then this one, you have to do it 4 times to get back to where you started. And so, meaning not all of these are exactly the same. Here's probably one of the most interesting facts. And that is, sometimes 2 different rotations will give you a different end result depending on which order you did them in. So consider the two rotations. We have this one and that one. So those two. So if I first do the quarter turn, and then I think it was that one that I did, but either way, you have this side facing you. Oh well, the camera. But going back to where I started, if I did that one and then that one, then I'd have the other side facing you. And so these are not the same. Now there's a few smaller collections of rotations that basically all these rotations give you themselves. There's no, you cannot get another rotation by doing any of these in any order. So one simple example is this rotation that turns it upside down, and the rotation that does nothing. If you do this twice, you get back to the nothing rotation. And so it's obvious that by doing nothing and by flipping it over twice, there's no other rotations that can be obtained. This one is rather obvious. There are other ones that are less obvious, which I'm about to demonstrate. But it's important to note that any such collection must have the nothing rotation, because, which we call the identity rotation. So now I'm going to name it that way. The identity rotation. And that's because if you repeat any rotation enough times, you'll get back to where you started. And so the identity rotation must be in any sub-collection of rotations such that you never get a new rotation that isn't in that sub-collection. Okay, so here's another simple sub-collection. It's all the rotations you have while keeping it face up, while not flipping it over. It's obvious that if you rotate it in a way that doesn't flip it, and then another way that doesn't flip it, then whatever the result is, that also doesn't flip it. And there are two other such sub-collections with 4 rotations like this. Well, this one had 4 rotations. 1, 2, 3, 4, the identity again. There are 2 other such, a group of 4 that are less obvious and less intuitive. And they are, well, the do nothing, which has to be in any sub-collection, the flips over these axes, so not the weird diagonal ones. It's this one, and this one, and the double rotation again. So those are the 4. And the idea is that if you do this flip and then you do the turning around, you get, well, I mean, you can see that these rings are on this side, and if we go back, that's the same as doing this rotation. And so you need to include both of those rotations in order to get a sub-collection that you don't leave with any combination of these. And then the other one is, again, the nothing, the double flip, and the 2 diagonal rotations. This one and that one. And as you can see, okay, so let's do this. If you do this diagonal and you turn it around, well, you get this side facing the camera, which is the same as if you did that other diagonal. And then there's a few more sub-collections, and those are all the flips and the do nothing. So there's this. Well, if you flip this way, you're not going to get to anything else. This one and this one again. You no matter how many times you do this, you could just get the thing itself and the identity. And those are all the rotations of the square. There are 8 of them.